Hey guys, welcome back to another video. And so today we're gonna figure out how to find the length of a singly linked list. And this is pretty explanatory, self-explanatory. We're just gonna find the length. One thing I do want to talk about before going into the code is about this little len. If you've ever used Python, you may know that if you have like a string equal to ABC and you try to find the length of the string by doing len str, it's going to return 3 because the length of this string is 3. And this is sort of like the generic length method uh, in Python that returns the length of whatever you're working with. And so by adding two underscores on both sides and then passing this self parameter, what we're doing is we're overriding this len method here. And by doing that, what we're saying is every time a variable with this class, with this singly linked class is called and we run the len method, it's going to run the code in this method as opposed to running the generic length method in Python. And so that's just basically that. And um, yeah, we're just overriding. So without further ado, let's just go through it. We are going to, oh, definitely if you guys want to try it on your own, definitely I encourage you guys to pause the video and try to figure it out on your own. If you guys do need any help, definitely come back and we'll work on it together. But hopefully you guys have done that by now. And so what we want to do, the first thing we want to set a count parameter is equal to 0 so that we start off with, so that we're able to increment the count and keep track of how many nodes there are. Then what we're going to say is cur is equal to self.head. So we keep track of the self.head. We keep track of the current node. And so we start off at the self.head. While cur, so while there is a cur node, we're going to increment the count by 1. And we're going to say cur is equal to cur.next. And so what this does is if we have A, B, C, D, we're saying our cur is equal to the self.head. And our while loop, since there is a current node at our head, we're going to increment our count, and then we're going to move to our next node by doing cur equals cur.next. And if there is a cur node here, we're going to increment count again, and we're going to move over. And then we get to the C, we increment count again since there's a current node, we move over. At the D, we check if there's a node there. Since there is, we increment count and we move to the next node. And since now we reach to a point where cur is none, this is going to fail. We're going to go out of the while loop and we are simply going to return count. So we just looped through everything until we got to none at the very end, and we just incremented our count every time. And yeah, that's just about it. If I run, we'll just run our stuff right here. We have A, B, C, D right here. If I make count is equal to len SLL, or SLL is our single linked list. If I run that and I print count, I'll comment this. I print it, we should get 4, and indeed we do get 4. And so I'll just add a couple more. So if we run that again, we get 7, and indeed we do have 1, 2, 3, 4, 5, 6, 7. And so that's our length method. Hopefully you guys found that helpful, and definitely stay tuned for our next video. All right, later guys.